Video, we're going to use limits to solve the first of the two fundamental problems in calculus. And we talked about that in the very first video. The idea is we have some random function f of x here. We are trying to find the slope of that function at a certain point. And the way we're going to do that is we're going to look at this thing called a tangent line. So this tangent line, it just barely touches the graph at that point, and the slope of the tangent line is what we are going to call the slope of the function, and we're going to call that the derivative. And so now we're going to see how we actually find that. Now to do that, we're going to take our point A, and we're going to pick a second point on the graph at some other x value here, call that x. And then we're going to draw a line between those 2 points. And because we have 2 points there, we can find the slope for this line. It's going to be the second y value, which is the y value at x, minus the first y value, which is the y value at a, divided by the second x minus the first x. And so this formula right here would tell us the slope. Now, the purple line is obviously not the same slope as the green line. However, if I were to go ahead and get a little closer here and draw that, then the new light blue line would be a lot closer to the green line. And the idea is that as you pick your second point getting closer to the first point, these individual lines, which they're called secant lines when they cross through 2 points, these secant lines are going to approach the tangent line. And so it turns out if we want to find the slope of f of x at x equal to a, and we are going to call this the derivative of f of x at x equal to a, and there's going to be a brand new notation for this. It's going to be f with a little prime next to it, parentheses a. There's even going to be another notation, and the reason why is that there was 2 different people that created calculus originally, and they had vastly different notation. And I think you agree that the f prime of a is simpler than this new one with this fraction dy dx. But regardless, there's all these here, they mean the same thing, and the way we're going to find it is by taking the limit as x goes to a of this fraction f of x minus f of a over x minus a. So this right here is how we can find the slope of a function at a certain point. And this is really useful, as we talked about in the first video, that when we have a position function and we take this slope here, what we're going to get is we're going to get the velocity. And so the velocity is a very useful thing, right? You want to know how fast you're traveling in your car. So this is the formula that's done. So basically your car is doing this formula all the time as you're driving. Now let's do an actual example of this here. Let's find the tangent line to f of x equal to x squared at x equal to 3. So the idea is I have my parabola that we've seen over and over and over again. And I come over here and I look at the x value of 3. And what I want to do is I want to find this line that just barely touches it. And whatever the slope of that line is going to be the slope of the function. Okay, so we have this formula here, the limit as x goes to, in this case, 3, of f of x minus f of 3 over x minus 3. And the function here is x squared. And if you plug in 3, you're going to get 9. And this is our limit here that we're going to use to find the slope. And notice that, as I said before, your first try at any limit is just to plug in the value of x. But if you plug in 3 here, you're dividing by 0. And as I said, you're going to very routinely be dividing by 0. And so we can't do that, but what we can do is we can go ahead and do some factoring here, do some algebraic simplification. And once we've done that, we can find the limit here by plugging in 3, and we get an answer of 6. So that means the derivative at 3, which is the slope of the line, is in fact 6. But we don't want just the slope. I didn't ask for just the slope. I asked for the actual line. And if this is all you give me, that's not going to give you full credit, because you need to know, your lines are going to be y equal to mx plus b. Or if you remember the point slope formula, y minus y1 is mx minus x1, which we'll go ahead and use that. So the y value at this point is 9. And the slope we just worked out is 6. The x value is 3. And there we go. So y equals 6x minus line. This is the tangent line to f of x equal to x squared at x equal to 3. And so in this section, if they ever want to ask you to find a tangent line, this is the exact process. And you'll have to work out this limit, maybe do some algebraic simplification or something like that. You're going to get your number. That will give you the slope. Then you need to use either point slope or slope intercept in order to write out the equation of the line, and then you're good. Now, the only thing I want to point out is that there's in fact a second way to solve this problem. Right? I showed you that f prime of a is the limit as x goes to a of f of x minus f of a over x minus a. The other way to do this is to write the limit as h goes to 0 of f of a plus h minus f of a over h. And the reason why this is working is, in your picture up here, what you're going to do is you're going to say, okay, I'll start at 3. I'll go a little bit to the right, 3 plus h. That'll be my new point. Get my secant line. And if you work out the slope from the secant line, you're going to get this exactly right here. And then as h goes to 0, your 2 points are going to go together, and you're going to get the same value. So it's just a different way of writing it. For finding tangent lines like this, I definitely prefer this first formula here. But when we start looking at finding the derivative as a function, I'd probably prefer the second formula. But we'll see that a little bit later. The last thing I want to mention here is that they're also going to use the words rate of change here. And I want to just kind of point out here the average rate of change. Whenever they say that, that means they want to find the slope between the final point minus the starting point. Whereas if they want the instantaneous rate of change, that's where they want the derivative. So just be careful whether they ask for instantaneous or average. Again, it's the difference between if you travel for 2 hours and you average 60 miles an hour versus am I traveling 60 miles an hour right this moment? Right? And if you think about it, if you ever go on a long trip, if you average 60 miles an hour, that probably does not mean you were going 60 at every point in time. You were likely going 60 sometimes, 70 others, maybe down to 50 for traffic, and so on. And so the average takes all of that into account, whereas the instantaneous rate of change is how fast am I going right now, right this moment. And so just make sure you know which one's which so you can answer the questions correctly.